Okay, as we start lesson 1.9, it is really important that you understand, the different terminology that we use that's related to geometry. There's symbols that are used. We can't be haphazard. We have to understand that when we're looking at some math symbols, what are they really telling us? And we all want to make sure that we are on the same page with that. So how many of you are familiar with that table that's already there? You knew that stuff that was already in there. So, it used to be anyway, in the 7th grade curriculum, that was where you really saw a lot of this, if not even a little bit before in your elementary grades. So, what is the difference though between when they write XY with a little line above it, like a dash above it, and they write XY without anything above it? What's the difference between those two, and why is that so important? So what is that table telling us? When there's a line above the XY, when we look at that, we should read that how? Todd? Line segment XY. When they don't have that bar above the XY, how should we read it then? What should we be getting from it then? What is it asking for then? Courtney? The length of the segment. It wants you to give the length of the segment that is XY. Well, where do X and Y come from? What do they mean by that? And what's a line segment? What does all that mean? What's a line segment?
It's a line.
It's not really a line, because a line goes on forever and ever. Chaser?
A line segment ends.
A line segment ends. It's part of a line, isn't it? And what does a line segment have at each of its ends? Dots, a point. Yeah, they have points at each end. So when you name a line segment, you actually are naming it by the two endpoints. So line segment XY tells you there's a point X at one end and a point Y at the other. And when it's just XY and they're asking you for the length of it, they're saying, okay, how far does it measure then from point X to point Y? What's the length of that line segment? Okay, and then we have, some other things in there also that I think are pretty self-explanatory. It says write triangle ABC in symbols. So in other words, if somebody looks at your writing there, they know that they should read this as triangle ABC. Well, it's pretty basic, isn't it? It's a triangle. Okay, we're going to have to do some calibrating here. It's a triangle with the letters A, B, C behind. Now, where do A, B, and C come from?
The alphabet.
They do come from the alphabet, yes. But if we're talking about triangle ABC, in reality, we're talking about what does the A, B, and C represent?
Angles.
Huh? Angles. Okay, that's one thing, but then they also, Courtney?
Angles of the triangle.
Angles of the triangle, but they also,
Points.
Points. They're actually points. They're the points at those corners of the triangle. Point A is one point, point B is another corner point, and point C, and yes, those do help form the angles. Okay, what does little m, that slanted capital L, and then a capital B equals 93 degrees in words? What is that really telling us to do? Todd?
The measure of angle is 93 degrees.
The measure of what?
Angle B.
Okay, the measure of angle B is 93 degrees. So if that was put, let's say that was in your homework, and all it said was little m, that angle symbol, B, and that's all it had there, you would be needing to know that it's asking you to give the measure of angle B. Okay? So, and then it says here we have this little statement right here. What's that in words? Chaser?
Triangle XYZ is similar
Triangle XYZ is similar
to triangle ABC.
to, and I think we've already talked about what does similar mean. What's that mean?
The same.
It's the same what?
Same shape.
The same
Shape.
Angle, same size.
but not necessarily, which means they have the same angle measures, right? but not necessarily the same size. They don't have to be the same size, but they have to be the same shape, which means that they have the same angle measures. Well, the other thing that similarity means is this. The sides that are corresponding, they're in the same position in the triangles. The sides that are corresponding, that are in the same position in the triangles, will be proportional. Or in other words, the same scale factor is used on all the sides. We talked about scale factor too. Okay, let's use the information given right here to label our diagram above. So what's the first one asking us for right here? What's that saying?
It's saying angle x equals 38 degrees.
The measure of angle x is 38 degrees. So we go up here and we say, right here, we can put a 38 degrees. We know that angle x is a 38 degree angle. Okay, now the next one, what is it asking us? It's telling us we have another angle measure, and that one is 93, and C is 49. So let's go get those in there also. B was how much? Or no, I'm sorry, which one is it? Yeah, B, 93 degrees. And C is 49. If you don't want to, let's say you write pen big and you don't want to have to put it in the angle, within the angle itself, another thing you could do is something like this. You could say, oh, 49 degrees, okay? You could do something like that also. Okay, then we also have some other things to label here. We have, what's this say to us? What's this saying again? No, it's not saying segment. It's really saying the length of segment XY is 18 centimeters. And this one is saying
The length of y is
the length of YZ is 15 centimeters and the length of BC is 10. Okay, so go ahead and let's go up there and get those labeled also. So the length of XY is 18 centimeters. And we know that the length of YZ is 15 centimeters. And we know that the length of BC is 10 centimeters. Okay. So now let's go and answer some of these questions then, given that information. Corresponding angles of similar triangles have the same measure. That's how they have the same shape, right? So what is the measure of angle Z then? So the measure of angle Z, that's not one that we were given. So this is the one we're looking for right there. How do we know what that is? It said the corresponding angles will have the same measure. Well, what angle is corresponding to Z? C,
Right.
A, B,
C.
I'm going to go C.
C. Think it's C. Why?
C.
Because it looks like it should be?
If you rotate it.
If you rotated it, it would be in the same position? Okay. Does anybody know how we can tell from the name of the triangles? Does anybody know how we can tell from the name of the triangles, McKenna?
In the order that they go.
In the order that they go. Okay. So somewhere up here, oh, right up here it said triangle XYZ, triangle ABC. That's how they've named them. Okay. So that means, in reality then, if we have triangle ABC that is similar to triangle XYZ, and we're looking for the measure of Z, then the corresponding angle with that should be in the last position of the name of the other one, shouldn't it? So it's C. So do we know the measure of angle C?
Yes.
What is it?
49 degrees.
49 degrees. So we just say, okay, well then this one has to be a 49-degree angle also. Okay, measure of angle A. What angle does the A correspond with?
X.
With X, because it's in the first position, like A is. Do we know the measure of angle X?
Yes.
What is it?
38 degrees.
38 degrees, so then that means A has to be 38 degrees. Okay, well now let's, we know that corresponding angles have the same measure, but corresponding sides don't have to have, do they? So, it's like, could you give me some sets of corresponding sides from those triangles, such as line segment AB corresponds with line segment XY, because AB and XY are in the same position, so they would be considered corresponding sides. So give me another pair of corresponding sides. Line segment BC corresponds with YZ. Okay, give me another pair of corresponding sides. Because there's a third side yet to these triangles.
AY is equal to.
No, they gotta come from the same triangle though.
AC.
AC corresponds with XZ. Yeah. So the first and the last letter correspond with the first and the last letter of this one also, right? Okay, so then let's write a proportion relating AB, BC, XY, and YZ. In other words, make a comparison. So if let's just start one out here. Let's say AB, let's put in the ratio, let's put the corresponding side to that. What side corresponds with AB? XY. So the relationship that AB has to XY should be the same as the relationship that BC has to what? YZ. Corresponding sides. Every pair of corresponding sides in that triangle actually have the same ratio. So now let's use our proportion model that we have to find AB. So AB is the one we don't know. We're going to call it X for right now. Do we know XY? What is it? 18. Okay. BC? 10 centimeters. Okay. YZ? 15. Okay. Well, you guys are really good at this now, solving proportions. Go ahead and solve for X, which will give us our length of side AB. I'm so saddened to hear those calculators coming out like this is a difficult division problem. Yes, Todd? You get 12 centimeters. So how would we write our final answer? We're not going to leave it as X. We would write it as length of AB. Remember, no line segment above it means length, right? Length of AB equals 12 centimeters. There's our final answer right there. Okay, any questions so far? Okay, then let's go to the back side. And I want you to fill in the blanks. If triangle ABC is similar to triangle DEF, then what are all the things we can count on? Could you fill that in, please, now from what we learned in the front? You don't have to fill anything in on the triangles. I'm talking about filling in the blanks like right here, 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 and here. Get all those blanks to fill in. See if you can finish the puzzle. Any brave soul wants to come fill it out for the class? Come on, McKenna. You can bring your paper with if you need to. That works. And it actually works better with these if you just hold the pen and use your finger. Finish yours if it isn't finished. Don't just copy McKenna. See if you can do it on your own. want to challenge McKenna on any of that, or you're feeling like it's all okay? Oh, we got a little bit of a challenge going on, maybe Jacob? She might have just written something wrong there, right? So pick up the pen so that you can write with your finger. It's going to totally erase your last one. Okay, thank you, Jacob. I'm going to put yours back, McKenna, just so, for a bit here so that, you don't have to feel bad. Is this what it was, McKenna? Is that yours? Before you take it away from you?
Yeah,
Okay.
that's
Okay. Anything else? Oh, Abby?
yeah. The B needs to be an E.
Yeah, measure of angle B does equal the measure of angle B. You probably meant E here, right?
Yeah.
Okay. Okay. So A should measure of angle A should be the same as the measure of angle D. Why do we know that without looking at the triangles? What if we didn't have the triangles here to look at? How do we know that they're equal to each other? They're what kind of angles? Corresponding angles of similar triangles. They're corresponding, and when they're corresponding, their letter names are in the same position in the name, aren't they? Yeah, so we can go with all of these. Now, when Jacob came up here and did this, is that really any different than this? No. Okay, here's the deal. Order does not matter when you're giving a line segment name, okay? So if you want to start with C and then A, so you want to go from here to here this way, you can, but it's really still the same side, okay? So in reality, we do have the three ratio relationships, and all of those should be proportional. Okay, well now that we practiced that, let's do one without a picture. We have a 4-letter name of something, so what do you suppose this figure is?
Rectangle or square?
Well, could be a rectangle, it could be a square, it could be... It can't be a triangle because it's got 4 corners, so it's at best, for sure we can say it's a quadrilateral. So we have quadrilateral MNOP that is similar to quadrilateral WXYZ. We don't know if this is square, a rectangle, a trapezoid, we have no idea right now. But we do know how to set up a relationship now. We know how to set up corresponding sides, correct? Because it looks like we need to find PM. Well, let's just, first of all, can we just set up, first of all the possible relationships there are at corresponding sides? So MN corresponds with what? WX. Okay, so the length of MN corresponds with the length of WX. They should be, like they can be compared to each other. Well, then we also have NO that corresponds with XY. And then we have lots of possibilities here. Remember, there's 4 sides, so we should be able to set up 4 of these, right? Well, we also have OP, which corresponds with YZ. And there's one left. What's it? Jacob?
MP equals WZ.
MP corresponds with WZ. Okay. We got 4 possible things here, but we only need 2 of those to set up a proportion, don't we? 2 ratios make up a proportion. Well, we're going to need the one, since we need to find PM, we for sure are going to have to use the one that has the PM in it. So right there, that one, we really need to use that one. Well, then which of those other 3 should we pick? Well, kind of important that they gave us this information, right? They said, you got this, and you got this. Well, this one's in the one with the PM, isn't it? ZW. Okay. NO and XY, we're going to cross our fingers and hope they're in the same one together. Are they? Yeah, they are. Okay, so those are the 2 we're going to use. We're going to say we can use the NO over XY equal to MP over WZ. Remember, is PW the same as WP? in this process? Yeah. Okay, so now we can substitute into our proportion. We have 2 over 2.8 equal to the MP that we're looking for. We're going to call it X for now. Over the WZ, which is the same as ZW, so 7. And we'll solve that. Well, we have to do our cross products. 2.8x equals 14. 2.8x divided by 2.8. 14 divided by 2.8. What happens? What do we get? 5. X equals 5. Which tells us then what? What were we looking for? We were looking for the, what about PM? The measurement, the length of PM. So we write our final answer like this. We say the length of PM, that's the short way to write it. We don't have to write all those words. The length of PM is 5 centimeters. Oh, you got to be able to set up these relationships, right? If you don't set up good relationships, good comparisons, then it's not going to work so well. Anybody got questions on that one? Okay, I want you to go to page 70 in your books. Page 70. And about a third of the way down the page, there's a little paragraph with a highlighted vocab word in there. Would you read that to yourself, please? Has anybody ever seen this before? It's called indirect measurement. And so what we can do is we can set up a triangle relationship. And I like to draw pictures for these. So we're going to do 2B. So underneath example 2, down at the very bottom of the page, we're going to do 2B. Where we have a woman who is 5.5 feet tall, casting a shadow 3.5 feet long. At the same time, there's a building casting a shadow 28 feet long, right? And solve a proportion to find the height of the building. Well, let's draw. I mean, we're not going to get fancy here. This side of the triangle is the, well, let's make that one a little bit smaller here. This side of the triangle is the woman's height. She's 5.5 feet tall, correct? And this, her shadow, is 3.5. So here's her right here. This, we can put a head on her. And this is her shadow, and then we're just going to connect this with a dotted line. Because we really have now a triangle here, don't we? And then we have this building. Do we know how tall the building is? No. No. So that's going to be our X. And we know, though, that the building casts a shadow of how much? 28. Okay. And again, we'll just, we have to have our little right triangle here. That's what we have. We have actually a right triangle form. So now we just set up corresponding sides. So 5.5 corresponds with X. The height of the person corresponds with the height of the building. This is one of the ways we could set it up. And the person's shadow corresponds with the building's shadow. So now again, we have a proportion to solve. Go ahead and get it solved. How tall is our building? 44 feet. Does our answer make sense?
Yes.
Is it reasonable? Because why?
It's bigger than the shadow.
Because it's bigger than the shadow, and the person was bigger than their shadow, right? So it seems pretty reasonable? Okay, so we're going to go with that the building is 44 feet tall. Okay. Any questions, concerns?